Okay, so what we are going to do is look at is called parenthesis balancing. Okay, so these are the three possible symbols you might have seen for parenthesis. Okay, so even in your when you're writing your code, you would have to make sure that the parenthesis that you write for in your code is balanced, in the sense that let me show an example here, like here. So here I open a while loop. So for this open braces, I should have a closing curly brace. Then I have an if block, I have an open brace and the ending brace. Then else if block that I open here and I end here. Then an if block inside, I open end, and else block, and so on. So if you write it like a nested a symbol of parenthesis, you should be writing it something like this. For the while, I have open parenthesis. Then for the if, immediately following that if block, I open the parenthesis and close it. Then for the else if, I am opening the parenthesis, and then inside that I have an if block, so I open it and close it. Then I have else block, so I open and close it. Then I close this else if. Then I have an else block, I open and close it. Then I close my while loop. So this is like a sequence of parentheses. So you want to check the sequence of parentheses is balanced or not. If the expression, the sequence of parentheses, you can call it as an expression, is not balanced, then your code will not compile. You will get a compile time error. So this could be used as part of a compiler design, whether a sequence of parenthesis symbols is balanced or not. So how we check it's balanced? You scan from left to right, and then you have to make sure for every open parenthesis symbol there's a closing parenthesis symbol somewhere down, but in a particular order. So how we do that? So let us look at this example using the logic using this example, and then look at the code. Okay. Alright, so if you think about this, as you scan this expression from left to right, we need to keep track of the open parenthesis symbols that we have encountered. Because as we scan through this string, somewhere down the line, we will be coming across a closing parenthesis symbol. Okay, and we then need to look at is that closing parenthesis symbol having a matching open parenthesis symbol that we have already come across. Alright, so let us look at the logic. So we'll use a stack for this because it's an application looking at. So we'll use a character based stack. So it's not an integer based stack. We'll treat the symbols as a character. So the code that we have seen so far for integer based stack, we can use it as also for character based stack, provided you change all the int there to char. Okay, so all the data type has to be changed to char, and then you can use it. So this is the first symbol we have come across. So that's the open parenthesis symbol. So we push it into the stack, and then we come across another open parenthesis symbol. So whenever we come across an open parenthesis symbol, we push that symbol to the stack. So now we come across a closing parenthesis symbol. So what we do is we pop the stack, and the stack currently then becomes like this. So we have processed until this so far. So now we have an open parenthesis symbol, so we push it to the stack. Now we have another open parenthesis symbol, so we push that again to the stack. We have a closing parenthesis symbol, so we pop this symbol, open parenthesis symbol, out of the stack. Now we have an open parenthesis symbol, push it. You see here, then now we encounter a closing parenthesis symbol. So the symbol that you're popping out of the stack is the corresponding open parenthesis symbol. Okay, so it will be automatically taken care of if the expression is balanced. Then you have a closing parenthesis symbol, so you pop out this. So then you have open parenthesis symbol, you push it. Then you have closing parenthesis symbol, and the corresponding open parenthesis symbol is there on the top of the stack. You pop it out, and you see this is the closing of that while loop, which began with this parenthesis symbol. So for this symbol, the corresponding symbol is what now is in the top of the stack. You pop out. So that means by the time you reach the end of the expression, after you read the last symbol, you have reached the end of the expression, the stack should become empty. So you start with an empty stack, push the open parenthesis symbols. As you encounter the closing parenthesis symbol, you pop the stack. And by the time you reach the end of the stack, end of the string, the stack should become empty. If the stack is not empty, so for example, so this is a balanced expression. So that's what we call it as balanced expression. Now, if let us say you have something like this, you have this entire thing which is balanced, but I have, say, an additional open parenthesis symbol. So what would be the case? So I should have pushed that additional open parenthesis symbol for which there is no matching closing parenthesis symbol. And then you scan the expressions by pushing the open parenthesis symbols and so on, and then popping them out as you come across close parenthesis symbol. So this symbol, the open parenthesis symbol, is the beginning of our while loop, and that is pushed here. And by the time you reach this symbol, the closing parenthesis symbol, this is what you will have, and you will pop this out. So even after you reach the end of the string, the stack will not be empty. So that will be the case if the expression is not balanced. Okay. So this is kind of the idea that we'll be using now. And we saw this example just based on this curly brace case. We could have a more generic code that will deal with any combination of these three parenthesis symbols. Okay. So again, I'm assuming that we have a character based stack. So the stack is the name of the class, which is a character based stack. So all the int there that we have should be changed to char. Then this is the name of my stack, so I could name it anything I want. I just label it as stack with a lowercase s. Then this is a string expression, and I have to use it enter expression. Now this expression or the sequence of parenthesis symbols, I am assuming I am not having any space in between two symbols. So I could use the cin itself to input the expression. If you want to enter space in between two parenthesis symbols, you could use the getLine function to input that string. So I am using an index variable to keep track of the symbols that I am going to scan. So index starts with 0. Then index less than expression dot size. So I'm using a while loop instead of a for loop. So here we are seeing a for loop to go through a string. So here I show how to use a while loop. So yes, any question? All right, so index less than expression dot size, it's true because index is 0, expression dot size has a length greater than 0. So get inside the loop and get the character at index at a particular index. So I label it, I store it in symbol as the variable name. So now I check if the symbol I have in that particular index is any of the open parenthesis symbols. So these are the three possible open parenthesis symbols, either this curly brace or this brace like this or a square bracket like this. Okay. So if any of this, if my current value of symbol is any of these three open parenthesis symbols, I push them to the stack. And I increment my index and I continue. So you should have seen this continue statement in 118 or 119. So when I do this, I am continuing the loop again. So the loop may have some more code, but once the control reaches this continue, it's not going to the rest of the loop for that iteration and continue to this condition part of the loop. And if the condition is still true, it will again execute the loop from the beginning. So index is now incremented to 1, and 1 is if it is less than expression dot size, that means 1 less than the length of the string. You then read the element at index 1 and see if it's any of the open parenthesis symbols and process it again. So that's the use of continue. Okay. Now, if the symbol is not any of the open parenthesis symbols, then is it any of the closing parenthesis symbols? So these are the three possible closing parenthesis symbols. If that's the case, our logic, as I explained in that example, is to pop the stack. So stack.pop. So the pop should return the data that was popped. In this case, it will be character. So I store it as in a character value, and I call it as top symbol. Now in this code, since we want to handle three possible parenthesis symbols, I want to make sure the symbol I pop has a matching open parenthesis symbol of the same type. So I compare the symbol I pop, which will be any of the open parenthesis symbols. So if top symbol equals this open parenthesis symbol, the current value of symbol, which is any of this closing parenthesis symbol, should also be of the same type. So it should be also the curly brace. If top symbol is this parenthesis, then the corresponding symbol currently looking at is also a closing corresponding same time. Then if the top of the stack is a square bracket like this, then the symbol that I'm currently looking at should also be a closing square bracket like this. So it should be matching. So this and top symbol equals this and this, or. So any of these three conditions are true, then we are okay. So we can continue the rest of the string. So I do index plus plus and continue reading the next symbol. Else. So this else is for this if. If none of these three conditions are true, that means we have a mismatch. So it might be like we pop open parenthesis curly brace like this, but what we encountered is not the corresponding closing parenthesis symbol of the same type. That's a mismatch. That's also a case of telling the parenthesis is not balanced. So once you encounter such a mismatch, you can stop the code right there and return 0. Why say 0 as the return value? Because you are looking at in the main function. So the main function is say int main. So you have to return something from main function. That's what you do as a normal return at the end of the main function. So we do the same thing here, return 0. So we stop the program right here if there's any mismatch in the symbols. So otherwise, it means if the open and closing parenthesis symbols are of the same type, we continue the rest of the string. Now you see I have another else part here, so that corresponds to this if else if. So if the symbol we read is any of the open parenthesis symbols, we push it to the stack. Else if any of the closing parenthesis symbols, we pop the stack and compare the symbol that we pop out with the symbol that we are currently reading and check if they are of the same type. This else means like we have not seen any open parenthesis symbols or any of the closing parenthesis symbols. So else means that symbol that is part of the expression is an invalid symbol. It's not any of the 6 symbols, none of the 3 open parenthesis symbols or none of the 3 closing parenthesis symbols. So that's when you come to this else block, and again you say the expression has an invalid symbol and stop the program right there. You don't need to scan the rest of the string. So go through the while loop like that, symbol by symbol, by using this index as the loop index. And then when you come out of the while loop, so this is a closing parenthesis for the while loop, you make sure check the stack is empty. If the stack is empty, then only you can say the expression is balanced. If the stack is not empty, then the expression is not balanced. Okay, any question on this logic? If it's just returned, does it go back to the loop? No, you cannot say return. You have to pass an integer value, because if you say return, the code will not compile, because you have to return a value, because return type in main is int. So you have to say return 0 or return -1, anything. So the normal practice is to say return 0, because we want to normally shut down the program. We don't, when you say return -1, it typically means you want to shut down the program because of some error. This is not an error due to the operating system or due to the program running. It's due to an error in the input. So that's the normal, still a normal shutdown. So, but anyway, you have to still pass some value for the return function, and we typically say 0. Okay, is that clear now? Any other question? So let us